Alright, first thing we want to do is create our blank spot. So to create our blank spot, I'm going to subtract 87 from each side. I then need to determine what's going to go in my blank spot. So we can either draw a picture, so we have x squared, and then I have 16 x's, which means I'm going to put 8 on one side and 8 down here. And then I need to figure out how many ones tiles I need. This is an 8 by 8, so I need 64. So I'm going to add 64 to both sides. Another way you could have thought about it is you take this middle term, so 16, divide it by 2, which is 8, and square it. And that's what you add to each side. So I'll get x squared plus 16x plus 64 equals negative 75. So then I'm going to factor this left-hand side. So here, this is an x, and these are 8. So this will be an x plus 8 squared equals negative 75. I then square root each side. Remember, when you take the square root, it's plus or minus. So plus or minus the square root of negative 75. Subtract 8 from each side. And we can't subtract 8 from the 75 because the 75 is inside a square root. So we would write this as negative 8 plus or minus the square root of negative 75. And then we can simplify the square root of negative 75. So first off, it's negative, so I can write square root of negative 1. Then I'm looking for a perfect square that divides evenly into 75. That would be 25. 25 goes in there 3 times. So this is I, this is 5, and this is radical 3. So I could rewrite this as 5i square roots of 3. So my final simplified answer should be negative 8 plus or minus 5i square roots of 3. Alright, so when using the quadratic formula, the first thing you want to do is make your equation equal 0. So to do that, I'm going to add 6x squared to each side so that the right side of my equation equals 0. So I will get negative 8x squared plus 4x and plus 14 equals 0. I'm then going to identify my a, b, and c. So my a is with my x squared term, so that's negative 8. My b is with my x term, so that's 4. And my c is by itself, and that's 14. So then I'm going to plug it into my quadratic formula. So that's our song, and in case you don't remember it, it's right here. So I'll replace all of my values. So I should get x equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 8 times 14 all over 2 times negative 8. So then I'll just do this math. So I'll get x equals negative 4 plus or minus the square root of 16. And this will be minus negative 448 over negative 16. Now I can change this into a plus positive. So when I combine those terms inside my square root, I'll get negative 4 plus or minus the square root of positive 464 over 16. And now I'm trying to look for a perfect square that goes into the square root of 464. So yes, 4 goes into it. So what I could do is write this as the square root of 4 times the square root of 116. Now, I can rewrite the square root of 116. 116 looks like it's divisible by 4, and it is. So I could do the square root of 4 times the square root of 4 times the square root of 29. So I get 2 times the square root of 29, which is 4 square roots of 29. Now I also could have written this as 464, and a perfect square that goes into it is 16, and it goes in there 29 times. Square root of 16 is 4 square roots of 29. So if you don't get the first number on the first try here, you can just continue to break it up, because we broke the 416 down into 4 and 29. and you'll still end up with the same answer. It's just always easiest if you try and find your biggest one first. So x equals -4 plus or minus 4 radical 29 over, this should be a -16. And then I'm going to reduce. So to help us remind which terms we reduce, we draw the heart. So a number that goes into 4, 4, and 16, I'm going to divide them all by -4. So look at x equals 1 plus or minus the square root of 29 over 4. All right, so our next problem talks about the discriminant. So your discriminant is the part that's just under the radical for the quadratic formula. So it is b squared minus 4ac. So first we're going to find out what the discriminant is. So to do that, I'm going to do a is 7, b is -4, and c is 3. So we get -4 squared minus 4 times 7 times 3. Well, this is 16 minus 84, which gives me -68. So this is my discriminant. Now what your discriminant tells you is it tells you the number and type of solutions you have. So if your discriminant is a negative number, which is what we have, our number is we are going to have 2 solutions, and the type of solutions we are going to have will be imaginary / complex. So because we had a negative discriminant, we will have 2 imaginary / complex solutions. Now say our discriminant was positive. So if it was positive 68, our number would still be 2, but this time we would have 2 real solutions. And then the last type it could be 0. So say our discriminant was 0. This means our number, we would have 1. I should have said type here. When our discriminant is 0, we will have 1 real solution. So since our discriminant was a -68, we are going to have 2 imaginary solutions. All right, so when simplifying radicals, so first off, I can rewrite this as square root of -1. And then what I'm looking to do is I'm trying to find a perfect square that divides into 150. So remember, your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, etc. So a perfect square that divides into 150 is 25. 25 goes into 150 6 times. So the square root of -1 is I. The square root of 25 is 5. Square root of 6 doesn't have a square root, so we leave it there. So our answer would be 5i square roots of 6. So in this video, I'm also going to do ones like 14 and 19. Now here we are subtracting. So when we're subtracting, we need to distribute the -1. So we'll get 8 plus 7i. And once we distribute, we don't need to write our parenthesis anymore. So we'll get 8 plus 7i minus 6 plus 3i. And then we combine like terms. So 8 and -6 gives me 2. Positive 7i and positive 3i gives me a positive 10i. All right. So whenever we have i's to some power and we simplify that, remember i's repeat every 4 units. So if I draw this chart, remember we have I, then I squared equal -1, I cubed equals -I to the 4th equals 1, and then we go back and it repeats. So then I to the 5th, I to the 6th, I to the 7th, 8th, 9th, 10th. So you could draw the circle and count. Or what you can do is divide the exponents by 4. because it repeats every 4 times. So on the first one, 14 divided by 4, well, 4 goes into 14 3 times with 2 left over. So 2 is going to be the same thing as I squared. So I to the 14 equals I squared, which is negative 1. So this term becomes 7 times negative 1. And I'm going to do this with each term. So 28 divided by 4 is 7. And our remainder is 0. When our remainder is 0, this is going to be the same thing as our I to the 4th power here. So I to the 28th is the same thing as I to the 4th, which is 1. So this becomes minus 6 times 1. 21 divided by 4. 4 goes into 21 5 times with a remainder of 1. So this means it's going to be I to the 1st. So I to the 21st is the same thing as I to the 1st, which is just I. So we'll get plus 10 times I. And then our last one, 31 divided by 4. 4 goes into 31 7 times with 3 left over. So this is going to be the same thing as I cubed. So I to the 31st equals I cubed, which is negative I. So this will be plus 5 times negative I. So I'll get negative 7 minus 6 plus 10i minus 5i. And then I combine like terms. So negative 7 minus 6 is negative 13. And then positive 10i minus 5i is a positive 5i. I'm also going to do, no, I'll stop here. I'll do the next one in another video. Now here we are multiplying these two together because there is no sign in between these two. So whenever I multiply, I'm going to distribute. So first I'll distribute the 6 to each term. So 6 times 3 is 18. 6 times negative 7i is a negative 42i. And then I'll distribute the 5i to each term. So 5i times 3 is 15i. 5i times negative 7i is negative 35i squared. Now before we combine like terms, we need to remember that I squared equals negative 1. So I'm going to replace this I squared here with negative 1. So really this is negative 35 times negative 1, or a plus 35. So now when I combine my like terms, 18 plus 35 is 53. And then negative 42i plus 15 is a negative 27i. All right. When we're dividing i's, we cannot have an I in the denominator. So what we're going to try and do is cancel them all out. So to do that, I'm going to multiply by the conjugate. So the conjugate is the same term, but the opposite sign. So this is a plus, so the opposite would be a minus. So I'm going to multiply by 3 minus 4i. And if I do it to the denominator, I have to do it to the top as well. Erase that. So on the top, I distribute the 6. So I will get 18 minus 24i. And on the denominator, I'll distribute the 3 to each first. So 9 minus 12i. And then distribute the 4i. So plus 12i minus 16i squared. So we talked about in a previous problem, I squared equals negative 1. So I'm going to replace this wonky I squared that I drew with a negative 1. So this becomes negative 16 times negative 1, or a positive 16. So then I combine like terms. So on the denominator, I can combine the 9 and the 16. 9 plus 16 is 25. And then these middle terms, negative 12i and positive 12i, should cancel out. So then I check, is there anything that I can reduce here? There's not a number that goes into all of them, so my answer would just be 8 minus 24i over 25. Hey guys, so I'm going to work out an example problem similar to the ones on your review. And this is going to be a system of equations where one's a quadratic and one's a linear. So first off, what I noticed is that both of these equations already equal y here. So since they equal y, that means these two equations have to equal each other. So I'm going to go ahead and set them equal to each other. Anytime you have a quadratic equation you're trying to solve, the best method is generally to try and make it equal 0. So to do this, I'm going to subtract 2x from each side, and then subtract 1 as well, so that this left side over here will equal 0. The right side then, I'll have x squared minus 7x plus 12. And we can solve this using a variety of different methods. My method that I like to use is factor. So the method of factoring we're going to use is factor sum. So I'm looking for factors of 12 that have a sum of negative 7. So two numbers that multiply to 12 and add to negative 7. That should give us negative 3 and negative 4. So the factored form of this would be x minus 3 and x minus 4. So we set each parenthesis equal to 0. So x minus 3 equals 0. And x minus 4 equals 0. So I get x equals 3 and x equals 4. So I'm going to have two solutions for this. One point is going to be where x is 3, and the other point is going to be where x is 4. Now I need to find the y values that correspond to these x values. So I'm just going to plug them into one of my original equations. Doesn't matter which one you pick. I'm going to pick the first one because it's a little bit easier. So I'm going to plug in x into this equation. Let's see if I can squeeze it in over here. So first I'll plug in 3. So when I plug in 3, I have 2 times 3 plus 1. So y equals 7. And then I'll plug in the 4. So y equals 2 times 4 plus 1, which would be 9. And so my answer where these two would intersect is these two coordinate points. Hey guys, so now we're going to focus on a system of inequalities with quadratic functions. So what I'm going to do is I'm going to graph each of these. So let's look at the quadratic first. I first need to find my vertex, so I'm going to do x equals negative b over 2a. So b is the number with x, so this would be negative 12 over 2a. So this is 2 times 3, because a is the number with x squared. So this gives me negative 12 over 6, which is negative 2. And this is the x coordinate of my vertex. To get the y coordinate, I'm going to plug in negative 2 into the x's in this equation to get the y. So the y coordinate is going to be 3 times negative 2 squared plus 12 times negative 2 plus 4. So this is 3 times 4 minus 24 plus 4. So 12 minus 24 plus 4 is negative 8. So my vertex point is the point -2, -8. So I'm going to go ahead and plot that point. So there's my vertex. Now if I look at my problem, there's a 3 in front, so to get my other points, I'm going to go over 1 and then up my odds times 3. So instead of going up my odds, 1, 3, 5, I multiply these by 3. So the first time I'm going to go up 3, and then I'm going to go up 9, and then I'm going to go up 15. So over 1, up 3, over 1, up 9, and then I don't have enough room to go up 15. Now this is a greater than symbol, so it means this is going to be a dashed parabola. Or sorry, that's a less than symbol. So it's going to be a dashed parabola where we shade down. So I connect my points with a dashed line. And then I'm shading down, so I put my point on my vertex and I go down, so I'm shading outside. It's hard to shade on this program, but kind of get the idea. Now for my line has a y-intercept at 5, so that's where to make my first point at 5 on my y-axis. And then my slope is 4, or 4 over 1. So I'm going to go up 4, right 1, up 4, right 1. Can't go any more that way, so I can go the opposite way. A greater than or equal to symbol means this is going to be a solid line where we shade up. I'm going to draw a solid line, and I'm going to shade above it. So the area where they overlap should be our answer. So I've got this area, and then all of this. And generally we just make it a little bit darker